Okay, so this is going to be a very short video, but it's just for those of you who had to go home early unexpectedly. So the idea here is to create an equation, a table and a graph from this statement here. So we know that it says 8 miles in 20 minutes. So we want to find our dependent and independent value. And in this case, our y value, right, it's going to be our miles. And the x value is going to be represented by the minutes. Okay, so when you think about it, we can actually write the number of minutes, the miles, the number of miles, depends, the number of miles that you're going to uh, run depends on the number of minutes you're going to be running, right? So the more time you're given, the more miles you can cover, the number of minutes. So which makes this the independent and this the dependent. So we can find, now let's set this up as our unit rate. So let's write that as a rate. So if you write that as a rate, we're going to get that it's 8 miles in 20 minutes, right? And if we change that to a unit rate, we want to see how much I can run in 1 mile. So we're going to divide 20 by 20. 20 divided by 20 gives me 1 mile. And then on top, 8 divided by 20, and I believe it's 0 point something 4. 8 divided by 20. Yeah, 0.4. So I can cover 0.4 of a mile. And sorry, at the bottom should be 1 minute. Right, so nothing too difficult here. So now if I have my unit rate, and this is, I call it my unit rate, I also know that K, my constant proportionality, is 0.4. And also I can find the equation of this line. Y equals kx, and I'm just going to replace the k with 0.4, and that's my equation. So to find the total, which is represented by y, I have to multiply 0.4 times the number of minutes I am going to be cycling. So this is my y value, my x, and then on the table I'm going to call this, what is it called, miles, and this is minutes. So we're going to say that 1 minute, 2 minutes, 3 minutes, 4 minutes. Let's just use those values. In 1 minute, I know I can go 0.4 miles. In 2 minutes, I'm going to double that, so 0.8. In 3 minutes is times 3, 0.4 times 3, or 1.2. And in 4 minutes, it's going to be 0.4 times 4, it's going to be 1.6 miles. So I'm going to use this information to create my table. My table here, this is my minutes, right? That's my x value always. My y value goes on top, and that's going to be representing miles. So because I have a lot of room, I'm going to make every 2 boxes here. 1 mile, 2 more boxes, 2 more boxes, 3, and I'm going to, my scale is by 1 by 1 by 1. And going up and down, I'm going to also use the 2 boxes, 0.4. I'm going to skip another 2 boxes, it's going to give me 0.8. Another 2 boxes is 1.2, and another 2 boxes is going to be 1.6. So 0.4, 0.4, 0.4. So, right, that's what we're doing. So let's plot our point. So in 1 minute, I go 0.4. Let me write a 0 here. 2 minutes, I'm going to go 0.8 of a mile. 3 minutes, 1.2. And 4 minutes, 1.6. I want to connect this. Put an arrow at the end. And this says that in my equation of the line, I'm just going to write it right here, is 0.4x. So it's a straight line. Oops. It's a straight line, number 1. 2 starts at 0, 0. And therefore we know it's proportional. Okay, so if you look at your table, what's the relationship here? How does that become? It's times 0.4. 1 times 0.4 is 0.4. 2 times 0.4, and it's 3 times 0.4, and then it's 4 times 0.4. So the magic number here is 0.4, right? So to go from our x, which is our input, to get our y, our final value, multiplied by 0.4. And that's what number 5 looks like. 6 might not be. 6 is the same thing. So again, we got to figure out who is what. So sorry, but that's not 6. This is 6. company can build 30 houses in 1 year, how many houses can the company build each month? Okay, so let me write this as a fraction right away. So the company can build 30 houses, and we want to know how many in a month, right? So instead of 1 year, I'm going to write that they can do 30 houses in 12 months. That's what the company does. And if I find my unit rate, what's my unit rate? 1 month. How many houses? I believe it's 2.5 houses. So that company can build 2.5 houses in 1 month. So my X value, my Y, which is my Y is going to be my actually let me write this over here, Y and X. So this is houses and this is months. What's the total number of houses? Well, the total number of houses depend on the total amount of months, right? So if I have 1 month, 2.5 houses, 2 months, 5 houses, 3 months is times 2.5, which is 7.5. And 4 months is times 2.5 again, and that's 10. So to go from here to here, right, it's a times 2.5 relationship for all of these, times 2.5, times 2.5, and then this, sorry, times 2.5 again. So my X is my month, and my Y is my houses. So once I have my unit rate, now let me write this unit rate over here, which is this guy over here. I know what K is, and K is the same thing as the unit rate, so K is 2.5. Can we write our equation? Yeah, well, I want you to use this. Y equals Kx. I just told you what K is, right? We just found out. So we're going to replace that K with 2.5 and X. Okay, so we start graphing. Let's use the table. So again, just like the previous problem, it's going to be 1, 2, 3 every 2 squares. I'm going to jump 1 unit. Over here, I'm going to go by 2.5. 2 squares, 2.5, and then 2 squares plus 2.5, which is 5, and then 7.5, and then 10, and then 12.5. Okay, so here's 0. 1 month I have 2.5 houses. 2 months, company can do 5 houses and keeps on going and going. And if we had more, we could graph more, yeah, right? And so on and so on, but we don't. So we're going to go up to here. Stretch the line. And, oh, I forgot to label this. This is the months on my X value. And number of houses is my, on the Y-axis. That's what it represents. A trucker drives 171 miles in 3 hours. Okay, so again, this is my Y and my X. So think about the depend statement here. The number of miles depends on the hours, or does the hours depends on the miles? I'm actually the number of miles that the truck driver is going to drive will depend on how many hours he's been driving, right? So the more hours he drives, the more miles he's going to cover. So the miles depends on the hours, which means Y is my miles, and X is my hours, right? So just in case we forgot, so this is the dependent, and this is the independent. So right away I'm gonna put X over here, Y, and my X represents the hours, and that's gonna be my X-axis, and here's gonna be my miles, my Y-axis. So let's write this as a rate that's given to us is 171 miles over 3 hours. Right, so we're going to divide top and bottom by 3, which means that in 1 hour he's going to go, I have no idea, 171 divided by 3, it's going to give us 57 miles per hour. Now that's the unit rate right here. And if we know our unit rate, we know that K is 57. And from that, I can figure out what the equation of the line is. The equation is Y equals 57x. So if he travels 1 hour, it'd be 57 times 1, so that means he went 57 miles. If he drives 2 hours, it would be 57 times 2. If he drives 3 hours, 57 times 3, and so forth and so forth, right? So that's what we would calculate. So this would be miles. This would be hours. Let's do 1, 2, 3, 4 again. We can just make life easier. So it's 57, 114, right, in 2 hours. 171 in 3 hours. We already had that. And then plus 57 again to 28. So again, 1 times 57 is 57, 2 times 57, and it's 3 times 57, 4 times 57. So we're always using 57 to find the total number of miles. So again, the easy part is the graphing, I think. I'm going to go 1, 2, 3, 4, 5. Notice the spacing is 2 squares among the units. And same thing, up and down, we're going to make the 2 boxes represent 57 miles. Go up 2, that's plus 57 is 114, 171, 228, and we can go over again and again. So again, 1 hour he covered 57 miles, in 2 hours he went 114, in 3 this much, in 4 this much, and so forth. Connect, straight line, push it out, and I'm done. That's all the things they're asking you to do. 4. Lay earned $312 and 6 on 6 personal training lessons. What's the constant proportionality? Well, y and x, money usually goes on top, right? So the total amount that she's going to pay depends on the number of training sessions, right? So that's what we would say. So which means that the total, the money, depends on the sessions. The more sessions, the more you pay. So again, so y is money, right, or the total. All right, total money. And the x is the number of sessions that you're going to hire a personal trainer. So let's write it as a fraction. We get $312 for 6 sessions, which means that each session that you're taking with this trainer is, I have no idea, 312 divided by 6, no, 312 divided by 6 equals 52. So each session that you pay the personal trainer to come over and help you costs you $52. So if that's my unit rate, we right away know what K is, and K is my unit rate, which is 52. I can use that information to find out my equation. My equation is going to be y equals kx, or y equals 52x, right? So I can use this. If I told you you had 10 training sessions, you would go y equals 52 times 10, and which means you spent $520. Right? So I can use this to find the total given the amount of hours that you use a trainer. So on the graph, here is going to be my sessions. I'm going to call my training sessions the number of training sessions. Here is going to be the money. 1 training session is 52. 2 training sessions is 2 times 52, which is 104. 3 training sessions is going to be 3 times 52, which is 156. And 4 training sessions is going to be $208, right? Times 52 times 52. So again, 2, 3, 4, 5. We're going to go by 2 boxes represent 52. Another 2 boxes is 104. Another 2 boxes 156. Another 2 boxes is 208. I'm going to go one more, and that's 260. So we can go on and on and on. We just don't have. So that's 0, 0. Plot your points. Straight line. And that's our final answer. So, like I said, short video. Okay.